And then we will have the truck. Let's have the car. And let's have the truck. The car is going to have a mass which is going to be 2,000 kilograms. All right, so this is going to be 2,000. The truck is going to be 200. Okay. I'm going to make it a little bit larger. So this is going to be 200,000 kilograms. Okay, so both of them are moving at 60 miles per hour. All right, so initially both of them are going to be moving at 60 miles per hour. And then you put the brakes on and they will both come to a stop. Okay, hold on. And while skidding, so which means that they both of them will experience kinetic friction. All right, so this coefficient of kinetic friction is going to be 0.85. All right, so what else do we have? Okay, all right, so G is going to be roughly about 10 meters per second squared. Okay, in either case, let me just draw this. I want to do a force diagram. All right, so put this on an X and Y coordinate system. And I'm going to identify the forces. So it's going to experience the static kinetic friction force. It's got weight. And also there's going to be a normal force acting. Okay, so identified all the forces acting on it. And according to this scenario, this thing is going to get to a stop. Okay, so the physics comms are done evidently. All right, so this thing is just going to skid a certain amount of distance. And this is the time it's going to take for it to come to a stop. So this thing is moving in this direction initially. All right, so it's going to have an initial speed in this direction, and the final speed at the end is going to be 0. Okay, so this is a good enough pictorial. All right, so which one is going to come to a stop sooner? All right, so let's go A, B, C. What is it that we want? Determine the weight, determine the normal force, determine the frictional force, determine the net force. Okay, so a bunch of stuff that we will need to figure out. All right, so let's use a different color. All right, A, determine the weight, determine the normal force, determine the frictional force. Okay, so determine the net force. Okay, and then we got to do more. What else do we need? Determine the acceleration, determine the distance that it's going to skid, and then determine the time it takes for it to come to a stop. So E is determine the acceleration. F is going to be the distance it takes for it to come to a stop, maybe expressed in terms of feet. F, G, and then lastly, the time it takes for it to come to a stop. Okay, a bunch of stuff that we need to do. All right. Okay, so we got a bunch of stuff. Okay, so that's A, B, C. Okay, okay, so let's solve the problem one step at a time. I will break it down. I'll do the algebra on the far left. All right, so A is determine the weight. The weight is straightforward, so it's going to be mg. Okay, and then we'll have the car on the side, and then the truck on the side. Car is going to be 2,000 times 10. Truck is going to be 200,000 times 10. All right, so this is 20,000. Okay, this is going to be 2 million. Okay, so we're done with part A. Okay, so part B is the frictional force. Okay, so part B is the frictional force. All right, so how do we get the frictional force? Frictional force is part B is the normal force. All right, so part B is the normal force. Guys, the normal force you will get from here. All right, so you will get it from the motion on the y direction. All right, so which means that that's what we have to do. All right, so along the y direction, you got the weight, and the normal force is the reaction force for the weight. So what we need to do is just take a look at the net force on the y direction, and as W is down. All right, so the net force on the y direction is what's responsible for the acceleration, right? Okay. Okay, so there's no acceleration on the y direction. This thing is not going up or down, so which means that the net force on the y direction is going to be 0. So what that means is the normal force is going to be the same as the weight. All right, so which means that the normal force of the car is going to be 20,000, and the truck is going to be 2 million. All right, so the next question is, what is the frictional force? All right, this thing is moving horizontally while experiencing friction in the backward direction. Okay, all right. I gotta go get the pacifier. All right, so here's the frictional force. The formula for the frictional force is, it's a static frictional force. It's gonna be mu sub s. No, it's not a static frictional force, it's a kinetic frictional force. Mu sub k times n. So the kinetic frictional force is gonna be 0.85 times 20,000. And okay. I changed the diaper. I think she's still hungry. There's no reason for it to be this cranky. All right, so the kinetic frictional force, that's for the car, and here's for the truck. It's gonna be 0.85 times, it's gonna be 2 million. All right, so, okay, guys, run the numbers. Give me the number for this one. What is it?
17,000 for the car.
Okay, so this is 17,000 for the car. Give yourself 5 points. All right, so we got 17,000 here, and then for the truck, is it 1,700,000, right?
Yeah.
All right, give yourself 5 points for that one as well. Okay, so we got the car, we got the truck. All right, so the next one is, what are we doing? Find the net force. All right, so let's move forward. Let's find the net force. All right, so D is the net force. All right, so for the net force, here's the setup that we will get to use. All right, so that setup is right here. Okay, now take a look at the net force on the x direction. All right, so you got the kinetic frictional force. It's going to be responsible for the acceleration, right? So the net force, in essence, is, this is the net force. Okay, this section is the net force. All right, so the net force on the x direction is going to be, for the car, it's going to be negative 17,000. And for the truck, it's going to be negative 1,700,000 newtons. Okay, so that's where we are. Okay, so we're done with that. Next one is, the next one is the acceleration. So this is what we need. Okay, guys, the acceleration is going to be caused by the net force. All right, so E is the acceleration. Net force is what causes the acceleration. All right, so net force divided by M is your acceleration. So for the car, it's going to be negative 17,000 divided by the mass of the car. For the truck, it's going to be negative 1,700,000 divided by the mass of the truck. Okay, so what do we got here? This is going to be negative 8.5, right? What is this? Okay. All right, so the acceleration of the car is going to be negative 8.5. The acceleration of the truck is going to be negative 8.5. Okay, question. Which one comes to a stop sooner if that's the case? All right, so let's take this one step further. Which one comes to a stop sooner? What is the distance that the car is going to skip? And let's figure out the time it takes for the car to come to a stop. Ready? All right, so let's focus on the car. Here's what the car is doing. It's coming to a stop. It's moving at 60 miles per hour. And within this distance, it'll come to a complete stop. Final speed is going to be 0 within this distance. And it's going to have a constant acceleration.
Professor K, may I ask, why is the mass on the acceleration 10 times less?
Okay, I'm not sure what you meant by it.
So like for the car, you have 17,000 over 2,000, but isn't the original mass 20,000?
All right, so the original mass for the car is 2,000.
Oh, I got that confused with weight. I'm sorry. I see.
No, you're fine. You're fine. I just want to make sure that I didn't make a mistake. Okay, cool. Yeah, this is for the car, right? So it's going to be 2,000 for the truck. It's going to be 200,000. Okay, so let's just focus on the car just for now. All right, so what do we don't know? What is the distance it's going to take for it to come to a stop? All right, so what's the distance does it take for it to come to a stop? Okay, so I'm going to assume that the acceleration is constant. All right, so I'm just going to grab these formulas. Okay, so what do we know? Which formula do we use? Okay, we're trying to figure this out, right? We know the initial speed. That's going to be 60 miles per hour. We don't know the time. We know the acceleration. So because we don't know the time and we don't know the distance, no good. All right, so we're trying to figure out the distance. We know the acceleration. We know the initial speed. We know the final speed. All right, so what's the initial speed in this case? This thing is moving at 60 miles per hour right here. So which means that the initial speed is going to be 26.78 or 79 meters per second. All right, so that's known. Assuming that the acceleration is constant, the only one that makes sense to use is this one. So let's use that one. All right, so square of the final speed, square of the initial speed, 2 times the acceleration times x. If you have any zeros, plug in the zeros before you're doing the algebra. All right, so I'm going to subtract the initial speed from both sides. These two will add up to 0. And then get rid of 2. Get rid of a. A's will cancel. And that's it. Here's the final equation. All right, so we're just focusing on the car just for now. All right, so what's the distance for the car to come to a stop? So this is going to be 26.78 or 79 square. All right, I'm going to place the negative up front. It's going to be 2 times the acceleration. That's what we got. All right, guys, somebody just run the numbers and give me the number. All right, so what's the distance for the car to come to a stop? I see 211.76. That's too much, I think. Is that correct? That's just, I don't think so. That's 211. No, that's 2 football fields. I'm like, that's not, it cannot be true. All right, I need a different answer. That's just unrealistic. That is not, I cannot be correct. Okay, so, okay, very good. 42.22. It's more like it. Okay, so it's going to be, those of you guys who came up with 42.22, give yourselves 5 points for that one. All right, so 42.22. It's going to be in terms of meters. All right, so give me a conversion in terms of feet. What is this, roughly? All right, every single person did the computation. Give yourselves 5 points. Okay, right or wrong, because you guys are contributing to the effort. All right, so it's 42.22. In terms of the distance, what is it? All right, so multiply by 3.28. And tell me what that number is. Okay, 138.5. So roughly 140 feet is what I'm looking at. All right, if there are skid marks, that's going to be about 140 feet. Give yourself 5 points. Okay, 5 points.